Right. Thank you, Mark. Again, I'm the director of engineering at ADF Engineering, and I'm going to be sharing my perspective or the perspective of an A&E firm on what we see going on, or have the trends that we have seen going on for the past several years in the oilseeds industry, both locally and internationally, globally, and some of the innovations, the changes, and the drivers for those changes that we've seen in the industry. The key things that we see, of course, as an engineering firm, we see the capital changes that tend to occur. And the three key things that tend to drive the capital spending at manufacturers, first of all, there are the regulatory changes. These are the changes that are often government mandated, but that, of course, will change from country to country. But there are some trends that tend to transcend national borders. Certainly safety and environmental are huge impactors. Food safety has become more of an issue in the past several years as well. There are also a number of financial changes. These don't tend to be new things that we've not seen before, but those are always big movers. And then the commercial changes are the things that are driven by consumers and consumer demand and ever-changing consumer demand. So just very quickly on some of those regulatory changes, the single biggest impact that we have seen as an engineering firm in the past several years have been regulatory changes, especially in North America and in Europe, impacting or from the impact of combustible dusts and combustible dust explosions. This is something that you're seeing driving significant amounts of capital spending all across North America and Europe. And events continue to occur, and that's what's driving this. In 2017, as many of us know, there was a facility in Wisconsin that had a horrible explosion at the Didion milling facility. And it just continues to highlight why so much attention is being paid to this area. Environmental changes also continue to impact the way companies continue to operate. Foremost amongst those for oilseed plants in particular, and especially those with refining operations, wastewater and handling, how wastewater is handled has had to become more complex and more stringent. So other changes such as this are continuing to occur. But food safety is another huge change. And this is something that, again, we're seeing across borders. There's a lot of demand. Consumers are much more conscious than they had been in the past about such things as how manufacturers are handling food products, things that go into food ingredients. One of the key things that is produced by in the oilseed industry are products like lecithin, and we're seeing more and more lecithin production beginning to occur within major oilseeds producers. They're adding lecithin technology or lecithin manufacturing to existing processes, and these are bringing a layer of food safety requirements that didn't necessarily exist in the past. When you're dealing with something that is a food ingredient, then all of the things like HACCP, which that's identifying the potential contaminants that can occur within a process. Anti-adulteration, that is the prevention of potential human-introduced contaminants or problems that can occur in manufacturing industry. Other things that are happening along are things like adding nitrogen blanketing to storage tanks and systems. You've got to be careful about that, especially if you are storing equipment indoors. When you bring nitrogen into the process, be aware that that can create other hazards as well. And all of this new regulation has required better documentation, and documentation would include updating P&IDs, new technologies to engineering firms such as laser scanning have become prevalent, and now you'll find most all engineering firms deeply involved in laser scanning, that is going into a facility with a scanner and mapping out a 3D model of the actual facility, not just a CAD rendered model, but one that's built from point cloud scan of that facility that gives very, very highly accurate information, especially about older facilities that are not well documented. Electrical health, another thing that has come to the forefront in recent years. So for financial trends, things that are continuing to occur, again, these are not new things. Cost savings has always been a concern, but the conflicting issue that we're seeing more of now is that consumers are demanding, or the customers are demanding, more flexibility in the types of oils, in their specifications, and that has conflicted with the ever-present need for reducing costs within the facilities. And what we are seeing are a lot of newer, smaller facilities that are being built. Most of the new facilities that we're seeing built, not all, but most of the new facilities that we see are smaller, and they're more automated than they have been in the past. And that is with an eye toward this flexibility. Where the older, larger plants, existing facilities, what we're seeing with them is that they're starting to add new co-products such as lecithin that bring higher margins and more cash into that facility. So the oilseeds industry, we have seen for a long time, has been very resistant to change, very slow to bring on new technologies. There are a few key vendors, you'll be hearing from a few of them later today, that are the key drivers of those innovations and new technologies. And some of these vendors have been taking on more and more vertical integration of the industry. They're taking on more and more pieces of the manufacturing site so that there are actually fewer vendors available to take on some of the new construction. So oilseeds producers tend to stick to their proven technologies, the things that they know, and it's very slow to bring in new technologies. But there are some great new technologies out there. One of those being vertical conditioners. We've seen them for years. We've seen companies like Solex and Crown out there at AOCS pushing the vertical conditioning technology, which is a great technology. That's the way to go. But we're seeing a lot of the manufacturers sticking with rotary steam tubes and older technologies because that's what they're familiar with, and it's very hard to make that step change for them. Hexane extraction, that's still the workhorse of the industry, is not going to go away soon, but we're seeing a lot more growth in older technology, actually, which is mechanical extraction. And you'll see as we start talking about commercial trends why that is. So change is happening. It is out there. You're seeing new things like palm oil and coconut oil replacing hydrogenation because hydrogenation is out. So we're seeing new things having to come in, such as transesterification as required for the palm oil. We're seeing a new awareness of a need for additional storage capacity in facilities. That is one of the main impacts that we've really seen from COVID, especially this past summer. We've seen a lot of companies that have had to slow down production, and with a fear of having to shut down a facility because demand has been reduced, they want to have more storage capabilities so that they can keep their facility operating longer at a slower pace without the concern of having to shut down. The other big change that we're seeing across the board is a new demand for on-site blending of oils. And that's something that had been done just by a few key suppliers in the past, but now it's being done more and more by even smaller manufacturers who have had to bring in this on-site blending capability, which involves a lot of automation and storage tanks, to be able to create custom products for different customers and to provide that flexibility that has been lacking in traditional manufacturing. Other things that are out there, we're seeing extraction of new facilities like sterols from fatty acid distillate. That's another big new demand area that we've seen. Other changes that are occurring in the industry, the digital transformation continues to happen. This is something that's been very prevalent for the past 3 to 4 years. More and more automation is beginning to occur, and that is, again, flexibility, the need for flexibility driving that. But we're also seeing now more of that requirement for remote access, and COVID is driving that even more. So now facilities need to be able to look at their key data, even to be able to make changes in the operation of their plant without even being on site. And that's something that's offered by that remote access technology that is available. The other thing that automation allows, it allows for faster changeovers because we're having to make more custom oils, more custom blends, and you can't afford to continue to have a lot of lost material due to that transition material, the changeovers that occur. So with automation, we find that is more minimized. So finally, the other big change that drives the industry, of course, are consumers. And consumers are very fickle, and they're always wanting something new. They always want the latest and the greatest. And the things that they're hearing that has significantly impacted the industry more than anything else is a trend toward, first it was non-GMO, but now it's more and more organic. They want organic materials. They want organic soybeans, organic soybean oil. Trans fats, as I've already mentioned, that's gone. And transesterification has kind of been put into that place to bring in other oils like palm. But there is some hydrogenation still out there. There are still some companies still doing hydrogenation, mainly for non-food applications, because lubricants and other materials still need that type of capability in their oils. But the organic trend has been very, very prevalent. And the key to that is, first of all, you can't use hexane and call it organic. And that, with the bulk of the industry using hexane extraction, it means it's been very difficult to find some of that organic capability. And that's why we're seeing that push toward more new, smaller mechanical extraction facilities. The other thing that we're seeing are some alternative extraction methods, and I'll get into some of those. But the other key issue, and this is something that has a tremendous impact on areas like like in Africa, where organic soybeans are available. Those soybeans, organic soybeans, are hard to find in the U.S. in particular. So the United States is having to import more than 70% of its organic soybeans. And that is a very high demand market now. So currently the U.S. is importing most of its soybeans from India. However, that is an area that is readily available to be able to get into, because there have been some issues with the harvests recently in India. So it's driving up the price of organic soybeans, and that is tremendous opportunity to get into that. So again, mechanical extraction, we're seeing a lot of that in new facilities, particularly to feed the organic oil demand that is growing very, very rapidly. There are some other new oils and new markets that are being penetrated. Biodiesel's been around for quite a while now. That market continues to grow. And we expect that market to continue to grow very rapidly in the foreseeable future. Other niche oils are starting to come into play. However, demand for those tends to be much smaller. Those tend to be those smaller manufacturers that are getting into some of those niche oils. And we're finding lots and lots of small players trying to get into that market. Not as much from the big name producers. And those niche oils involve some other extraction technologies too that we are seeing quite a bit of. Ethanol extraction for some new materials with ethanol. There's a claim that they can maintain the organic claim when using ethanol. And the other that we're seeing is CO2. CO2 is a very unique technology. It's fairly capital intensive, but this is something that's used for things like CBD oil. And it offers a very, very clean oil, very, very high purity, because it's driven by changes in pressure more so than changes in temperature. And you can get a very, very clean material, and it doesn't add heat to your meal. So if you've got a meal or a protein concentrate that is very sensitive to temperature, this is a technology that's available. Algal oils, we're still seeing having trouble penetrating the market beyond fuels, but it is still out there. They are still making that push. Protein isolates are the main thing that we're really seeing from a co-product standpoint, where many of the smaller facilities are making more money from the protein isolates than from the oil. So that's definitely been a push for not only for human food, but for animal feed and aquaculture, which has a huge demand for these protein isolates. And they have some very, very interesting materials that they're looking at for protein. With that, I think I am about done. So I will start sharing.
Matt, thank you very much for that presentation. while we wait for the audience to submit some questions via the chat or the direct mechanism, I had a question. You mentioned ethanol and CO2 extraction technologies, and it seems like ethanol would be a little bit easier, a little bit more, conventional types of things. And I know there's a higher heat of vaporization that you would have to deal with versus ethanol. But, what are the sort of the pros and cons if you were thinking of sort of migrating from a hexane extraction to an ethanol extraction?
Well, the big problem with ethanol extraction, of course, is the recovery of that ethanol is fairly difficult because, as you know, when you try to distill it, ethanol creates an azeotrope. So you've still got water in it. You've still got about 8% water in it that you've got to deal with. And if you want to put that back in your extractor, well, that'll turn your meal into mush.
Oh.
So that's a problem. So you have to. We see it more on some non-soybean type of products that don't have that sensitivity to the moisture. Otherwise, if you're going to use that, you'd have to have some drying technology like a mole sieve to take the water out of that ethanol if you're going to be able to recover it. And you need to be able to recover it to keep it economically viable.
Sure. Well, if I guess, I was thinking, it would be kind of substitutable, but if you have to put in a mole sieve, drying distillation system, then that brings the capital cost up a bit.
That's exactly right.
Yeah. Okay. Let's see if there's any questions from the audience yet. There's one question here. It's asking a little bit of detail about the trend in organic soy oil. Do you see it growing more in the EU or in the US?
Actually, the growth rate would be higher in the US. That's because they're starting from a lower level. Organic demand in Europe has been high for a long time. Therefore, that's already... the growth is there, but that's already plateauing. It's already the standard. In the U.S., it's something that's growing very fast, but it's still way behind what you find with traditional soybeans.
Okay. You also mentioned transesterification. I know in Europe, it started out being largely chemical enteroesterification. And as I mentioned, or maybe I didn't, I was involved in some of the first commodity-based enzymatic enteroesterification. I just wondered, what do you see around the world? Is it more popular in certain areas, or is it, what's driving sort of the difference between chemical and enzymatic these days?
I'm really seeing more and more of the enzymatic everywhere we look.
Everywhere.
So, especially in areas where soybean oil is being imported. So these are facilities near the coasts that are bringing in shipments of palm oil from Southeast Asia or from Africa. You'll see a lot of those facilities building more and more of the enzymatic esterification. I really haven't seen much at all of the chemical. Okay.
Let's see if there's any other questions from the audience at this point. No, doesn't appear to be. You also mentioned just a little bit about CO2, and it was primarily being used for some really higher value oils. Do you see, other than the CBD, CO2 being used for any higher value vegetable oils, or is it largely kind of in that almost pharma neutral?
I'd say it's unlikely. It would have to be very high value because the capital cost of the CO2 systems makes it prohibitive for any large facility because you're dealing with some fairly high pressures to maintain that liquid CO2. And that lends itself to a very small processing.
Yeah. Okay. Well, like you said, it's likely that we'll see hexane for quite a while, I suppose.
It's not going away.
Not going away. All right. Well, I think that's, let me see if there's any questions that have popped up. Nope. So that pretty well concludes the first session. And thank you very much, Matt, for making yourself